This video looks at probability and in particular correlation and causation. When we're talking about these sorts of things, we're talking about probability in real life applications. Up until now, you've probably been quite familiar with doing simple probability. So that might be things like surveys, how many people had a Vegemite sandwich in their lunchbox and those sorts of things. Games of chance, so anything to do with dice or card games or spinners and all of those sorts of things. And we also see that sort of probability in gambling, which is a real life application, but it's still looking at things where there's a clear outcome and clear factors. When we look at real life situations, they're often a lot more complex. There's often multiple factors going on of does one thing make one other thing more likely? And often they will include unknown factors or changing factors. So what this area of statistics and probability tries to do is to look at what's going on and try to make some judgments. Firstly, we need to cover some terminology. So correlation means events which occur together. Causation is when one event has made a second event occur. A hazard is a situation which may make an event or some harm likely. But a risk factor is a statistical correlation, not a causational link, and we'll come back to that in a minute. So a hazard in the sense of there's a puddle that someone could slip on and hurt themselves is different to a risk factor, and we'll discuss that in a minute. Now we're going to talk about correlation and causation. So you'll often hear people say correlation does not prove causation, which is perfectly true, but a lot of the time we assume that it does, and that's where the problem lies. Sometimes correlation is because of causation, but there can be other factors. So the first event may have caused the second event. So I have an umbrella with me today because it's raining. So in that instance, the rain caused me to have the umbrella. So in that case, the correlation, the rain and the umbrella, it is causation. The rain caused me to bring an umbrella with me to work today. Sometimes it's the other way around. Sometimes the second event may have caused the first event. So if I say that people who have asthma puffers in their bag are more likely to suffer from asthma, therefore asthma puffer carrying makes you more likely to have asthma, so don't carry a puffer and then you won't have asthma. That's incorrect because that's the wrong way around. It's not the puffer that caused the asthma, it was the asthma that caused you to carry the puffer. Sometimes there could be a third factor which has caused both events. For example, today I have a really lazy lunch and it's exam block. Therefore, exams cause me to have 2-minute noodle lazy lunches. Exams have nothing to do with what I have for lunch. What the issue is here is that it's the end of term and everyone's stressed and tired, and I didn't have time to make lunch on the weekend, and exams happen at the end of term. So the issue here, the causational issue here, is that it's the end of term, and that means that people are short on time and often tired and stressed. And so it's the end of term which causes exams and which causes me to have a tragic desk lunch. So sometimes there's a third factor. When we talk about risk factors, we're talking about things at a population level, not about individuals. We're also referring to correlation, not causation. So if we say this group of people is more likely to suffer from this thing, that may not even mean the majority. For example, there might be one group of people that's generally people might suffer from a particular illness at, say, 5% of the population. There might be one group of people where that particular group suffers from that disease as 10% of that group. So that would be reported as that group is twice as likely to have that affliction than the rest of the population. Now that doesn't even mean the majority of those people have that. It means that it's the 5% versus the 10%. So when you hear that terminology, you have to realize what it's being compared to. We do this sort of risk factor modeling to assist with decision making at a population level. It's not about individuals, it's about populations. So it doesn't mean if an individual stops carrying their puffer that they will stop having asthma. Okay, it's about making policy decisions and public health decisions and things like that at a population level. In summary, correlation does not prove causation. Sometimes correlation is because of causation, but that in itself doesn't prove it. Sometimes the second thing caused the first, and sometimes there's a third factor. Risk factors relate to population level analysis of correlation, and they're based on correlation only, not causation. And just as to give you a little bit of that laugh, I'll leave you with this cartoon, which hopefully you'll find funny.